So this is equal to K Q1 Q2 over R squared. Does everybody see this? This is the before, and this is the after. R squared. Yes, not R squared. I do that to make sure that you're watching. For some reason, I'm determined to make Coulomb's law out of potential energy. All right, so at this point, it's a proton. We know the mass of a proton, right? What do I do about these two charges? One of them is which? The proton. So again, I know the charge on a proton, but the other is two protons. So I'm going to have proton, proton times 2.
Yes.
Everybody good with that? Yes, Melissa?
Are all the protons the same?
All protons have the same charge. So in the helium nucleus, the 2 protons that are there have the same charge as the
no
3
matter
protons.
what chemical.
In fact,
Okay.
that's a good question. It turns out there's no way to get any even small variation in the amount of charge on electrons or protons. It's a fixed number that never changes. The mass, we can kind of effectively say the mass might change when we get to relativistic stuff, but the charge seems to be immutable, does not change. All right? So they said that they want this to happen when R is equal to 10 to minus 15 meters. K, I know the 2 charges. R is what they've given me. It's a proton, so I know the mass, and the only thing I don't know is the velocity it's going to make this happen. All right? And that's how you basically approach the problem. Yeah. All right, so we've got 2 big concepts going on in this chapter. We've got the concept of Coulomb's forces, all right, which we have from here. And we have the concept of potential energy as it's tied, and kinetic energy as it's tied to the system. Now, I kind of sort of glossed over this, but I want to make sure it's really, really clear in all your minds. Last semester I told you that we had 2 conservative forces, and what were they? Springs and gravity. We've now added a third. Electrical forces are conservative. Electrostatic forces are conservative. And we'll learn that there's a twist to this. So that's why we can do this. If they weren't conservative, we couldn't do this. What does it mean when I tell you that something's conservative?
Energy's not lost.
That the total energy never changes, right? The total energy never changes in a conservative system. That means that the only way to change the energy is to have a non-conservative force act on it. All right? The only way you can change the energy of a system is to have a non-conservative force act. How do I know absolutely that I'm not possessed of any conservative forces? What does it mean? So the total amount of energy I have would never change. So if the energy of my body was conservative, I could run around the world and never lose any energy. There's just so many reasons that's not going to happen. All right, but no, no, we're not conservative. That's why we eat. That's the whole reason we eat, is to replace the energy that we use up during the day, and that we radiate and all this stuff. But with charges, and this kind of problem, it is conservative, so that allows us to do this. All right, Coulomb's law, point charges only. Energy like this, typically we deal with point charges at the atomic level. But what we're going to eventually do is we're going to start looking at aggregates, distributions of charge that still allow us to make solutions to problems. But for right now, we're just sticking with the point charges. All right? Yes, Terry?
So for potential energy of the charges, you talked about 2 charges. What if I had a system that has more than 2 charges, 3 charges next to each other? Would there be potential energy for them to the system?
Okay, if you have 3 charges, you have to add up all the possible forces among the 3 charges if you want to find the net. So if I have 3 charges, I'm going to have 3 independent forces.
No, I'm talking about the energy system. Can they consider the energy system for 3 different charges?
Sure, I mean, you just have to, it's just more calculation.
More calculation.
And by the way, on the homework last time, I made an incorrect comment about what they were looking for. It turns out the problem's much, much easier than what I told you. If I have a system where this is like 2 meters, 2 meters, 2 meters, and all these charges are the same, I don't remember what they were, 10 to the minus something. We'll make something up, 10 to the minus 50 volts. All right, and I bring in another charge. They ask what the potential energy of this charge is, not the potential energy of the system. So to ask what the potential energy of this charge is, how many computations do I need to make? I would need to make 3, but it's actually the same computation 3 times.
Same charge.
Because since I'm using potential energy and it's not a vector, I have the same values of the 2 charges, the same distance between them. So you basically calculate one answer and multiply it by 3 to to get the answer they're looking for. What I had told you was to find the total potential energy of the system, which would require 6 calculations, but they don't want that. So you're good, it makes it really easy. Because the charge you put in here is the same distance from all 3 charges, we have the same R. And because the second charge is in all cases the same Q, the potential energy of each pair is the same, and it happens 3 times because there's 3 charges that this one is interacting with. And because it's a scalar, I don't care about the distances or the directions or anything else, I just get the numbers. Are you good with that? All right, so the last word of caution. So today, we're on, that is the end of our first lovely week. We have 2 weeks and then an exam. And the way this is going to work is the material on the next week is, of course, due again on the 6th. But I put chapter 16, the first part, which should be due on the 6th. I postponed it and put it on the 10th. This is important, guys. 10th is a Friday, not a Monday. That's because our exam is on Monday. So I want your homework done and out of your hair before the day of the exam. All right? And so what I've got to tell you is there's a lot of work there because you're going to have one set of assignments that comes a little earlier than you're used to. So if you're used to doing stuff on the weekend, you're going to be screwed. So you've got to plan ahead that that last assignment is coming on Friday midnight and not on the following Monday. All right? Because I need that out of your hair so you'll study for the exam. I don't want anybody getting caught flat-footed on this. And yes, there's only 2 assignments that Friday, but one of those assignments, according to even the computer online, is 1.5 hours. The reason for that is because it's actually 2 assignments. I lumped them together to make it so that, because I didn't want to put them out on the Friday. So it's not, don't panic because it's actually 3 assignments. I've written 2 things, but it's actually 3 assignments. That's why one of them's long. All right? But if you don't start getting on top of stuff and in front of it, you're going to be really messed up by the time the test rolls around. Anybody got any questions about that? Yes?
On the system, they take your points off for time or things like that.
It's still doing that to you?
I mean, well, the last time I did, the question was that correct?
Go back and fix it. I've changed it. You should be able to go back and get any points you missed.
No, like if I.
Now I'm getting missed different stories. Manuel said he could.
You could? Yeah. I tried it again, and I said I did, but it hadn't worked. I'll try it again, but I just checked last night.
No, if it wasn't, why is it picking on me?
Yeah, it's the one I already did.
Well, you had started before, though, hadn't you? Anyway, here's the deal. So it's only the first assignment, right?
Yeah.
So if, you know, as we roll down the road and you can't go back, I say this, I'm going to really regret it, but work on it really hard. And then I'll give you all full points if anybody doesn't have full points. On the first assignment, all right? All right, so guys, I will see you on Monday. Have a weekend. I won't say a good one because I want you to do physics all weekend.
Do you guys know it? Tuesday, right?